Okay, good afternoon, everybody. Today we have our very first IDS undergraduate student project talk. This talk is about data-centric AI, in particular with the program software called ActiveClean. The students under the supervision of PhD student Brian Formento over the summer has worked towards building a Python package to implement the ActiveClean paper. So as we know now, the data-centric, there's a focus on data-centric AI, which is focusing on making sure that the data is of good quality rather than focusing on the quantity of data. And this is the interesting work that I think the undergraduate student has worked on, and I would like to invite the student to share about their project, summer project, and then so that we can learn something about data-centric AI as well as the ActiveClean. All right, Brian, you want to say anything to introduce your students?
Yeah. So hi everyone. Basically, I'm just waiting for people to join from the lab because I went around and asked them to join. So there's a few more people joining.
Okay.
But yeah, so there are 2 undergrad students. I've been generally impressed with what they've been doing for the past 3 months. And for the next year, they're looking to actually do another project in this area or something related to this. So yeah, I'm really looking forward for this presentation. And yeah, I'm just gonna leave it to them to present it.
All right. So Wei En or Neeladri, who are both third-year students now at the School of Computing, will be presenting on their project. So Wei En, are you going to present first?
Hello, yeah. I'm Wei En. I'll be presenting first. I'll share my screen. Sorry. Okay, hello. Yeah, so good afternoon, everyone. I'm Wei En. Good afternoon, Prof. I'm Wei En together with Neeladri. We'll be sharing more about our data-centric AI project, ActiveClean. So as mentioned earlier, the theme of our project is data-centric AI. So I will briefly start with an introduction to data-centric AI before sharing more about our project. So what is data-centric AI? So according to Andrew Ng, quite a well-known figure in the field of AI and ML, he defined data-centric AI to be the discipline of systematically engineering the data needed to build a successful AI system. So there are 2 main approaches to AI, the model-centric approach and the data-centric approach. So the model-centric approach aims to iteratively improve the model or the code to improve the performance of the AI, while the data-centric approach aims to improve the data or enhance the data sets to improve the performance of the model. So the performance of an AI model depends on both, as the performance of AI depends on both model and data. By improving the data sets, the performance of AI can be improved as well. Yeah, so moving on, I'll be sharing more about a recent innovation in the field of data-centric AI, which is PICET. So PICET is a framework to safeguard against data corruptions during both training and deployment of machine learning models over tabular data. So it's designed as a plugin that can increase the robustness of any machine learning pipeline. So in order to, so during training, PICET identifies and removes corrupted data points from the training data to avoid obtaining a biased model. And during deployment, PICET flags corrupted query points to a trained machine learning model, which is the self-supervised deep learning model, PICET-net, that will result in incorrect predictions due to noise. So PICET can consistently safeguard against corrupted data during both training and deployment of various models, from SVM to neural networks, and can beat a diverse array of competing methods. Yeah, so moving on, I'll be sharing more about ActiveClean, the main research paper which we referenced in our project. So ActiveClean allows for progressive and iterative cleaning of statistical modeling in statistical modeling problems while preserving convergence guarantees, and was developed by Krishnan and a team in 2016.
Sorry, Wei En,
Yeah.
Pickett, the relationship with Pickett and ActiveClean, what's the relationship?
Oh yeah, sorry. I mean, there's no relationship. It's just sharing more about how we. If given more time, we would have considered research into Pickett as well. But ultimately, our team decided to.
Okay, so
yeah,
Pickett is a newer work. Is that correct? ActiveClean is 2016.
Actually, I'm not too sure when Pickett.
Okay.
Yeah, but it's relatively new.
Okay. But ActiveClean was published in 2016 before Andrew Ng had this concept about data-centric AI, right?
I'm not too sure, but yeah, I believe so.
Yeah, okay. But it's useful for of the quality of the data. All right, okay.
Yeah. Yeah, so there are a few alternatives to ActiveClean. So it is the native mix, native sampling, and active learning. So for each of these methods, a brief introduction is here. So for native mix, it draws a random sample and merges the clean sample back into the data set.
And I think it's naive mix, not native.
Sorry, yes, naive mix. My bad. Yeah, naive mix. And naive sampling is, in comparison to naive mix, it only retrains over the set of records that have been cleaned so far. And for active learning, the samples are picked using active learning, and the model is retrained over the set of records cleaned so far. So in comparison, ActiveClean can achieve a comparable model accuracy while expanding a fraction of the data cleaning effort. So so the approaches were evaluated on true matrix model error, which is the distance between the trained model and the true model if all the data was clean, and test error, which is the accuracy of a model on a held out set of clean data. So ActiveClean consists of a few components.
So, sorry, can you go back to the previous graph and explain a little bit more? What are dirty, AC, O, NS, AL, and N?
Oh, so
what are we looking
AC is
at?
ActiveClean, NS is naive sampling, active learning, and naive mix.
Okay, so what we are seeing here is that the green one, which is ActiveClean, is doing quite well compared to the so-called the best ground truth, which is the O, is it? The purple one, right? O?
Yeah.
Yeah, okay. I understand. Okay.
Yeah, so so it's evaluated on test error and model error.
Okay.
Okay, so the ActiveClean comprises of these four components: the detector, sampler, cleaner, and updater. Neeladri will share more on the different components and our project.
Okay. So yeah, as I said, there are the four components: the detector, sampler, cleaner, and the updater. Yeah, next. Okay, so first component is the detector. So what the detector does is it uses the previously cleaned data that is, say, provided by the user, and we use it to sort of it returns two important aspects of a record, which are whether the record is dirty, and if it is dirty, what attributes are dirty. Right now, we are using a basic binary classifier using SVM to do this process, using it for this component. Yeah, next. Next, we have the sampler. This component allows us to sample the data using two different techniques. First, we have uniform sampling. Here, each data point has the same probability of being chosen. And so it just takes a uniform sample among the data from the data set. And next, we are using the aforementioned detector to sample the data set. We first use the detector to output the probability of data being dirty, and then we use this probability to take a weighted sample. Yeah, next. The next component is the cleaner. So after we get the sample from the sampler, we pass it on to the cleaner where the data is being processed and output it to a Excel sheet. In this Excel sheet, the user can use their own functions and clean the data by themselves, or use to clean the data by themselves. And after they're done, what the cleaner does is it processes the data from the Excel sheet and into a format that can be used by ActiveClean. The cleaner will also update the existing data in the processor with the clean data. Okay, last but not the least is the updater. This component calculates the gradient from both the clean data and the dirty data and proceeds to give the total gradient that leads to the fastest convergence. The weighting takes into account several factors like sampling probability, sample size, proportion of data clean, and the proportion of data that is still dirty. Yeah. Okay, so moving on to our project, what we have accomplished and the several challenges we have faced in while making this project. So first, so the main reason we started doing the project was because there were several limitations with the existing code. First of all, the GitHub script that was provided along with the paper was quite messy and hard to use. And the provided script only worked for the IMDb dataset and only for SVM models. Like there were no deep learning models that could be used along with it. So yeah, next. So our project objectives became refactoring the existing code so that it is easier to read and access, and also integrate the framework with TensorFlow. This is so that the framework can work with any type of TensorFlow model. So the user can just give in any, say, TensorFlow model, and the active framework just works seamlessly with it. Yeah, next. So as for current progress, we have set up a GitHub repository. We have refactored the code into the 4 different components, and we have written the documentation for it so that it's pretty easy to read and access. And also we have made it work with the SVMs as in the original paper. As of right now, we have also started the integration with TensorFlow. Yeah, next. Okay, so on the challenges we have faced while working on the project. Yeah, so one of the issues we faced was that the formula in the paper for the updater was extremely basic, and they demonstrated that it only showed good results with SVMs. Like they didn't show it to be working well with any deep learning models or anything of that sort. So we had a difficult time sort of finding a method to generalize this update for all types of models like deep learning models. Another issue we faced during the process was that we needed to modify the TensorFlow model that would be provided by the user so as to integrate the entire framework together. And for this, we would need to go pretty low end, and also we need to modify so that it would use the sampler and the detector of the ActiveClean framework. Yeah, next slide. So for the future plans of our project, yeah, with more time on our hands, we look forward towards completing the integration with TensorFlow, and also look for better strategies for a better detector algorithm, like improving the sampling process, like using importance sampling, for instance, and also creating a generic model updating method. Further, we would like to do extensive testing of the code using TensorFlow to ensure that our project works perfectly. And at the end, we would like to publish it as a Python package on PyPI. Yeah. Next. Yeah, and these are some of the references for the various various references we used throughout the project and throughout the presentation.
So Picket is 2021. Huh?
Yeah, it's pretty recent because it was done. It's even like used for like finding out spam and stuff like that.
Okay.
Yeah.
Great.
Yeah.
Thanks.
Thank you.
Any questions from the audience?
Yeah, I suppose I could have a question. So thank you for the presentation, Wei En and Neeladri. So I was wondering, if you had to start this project all over again from scratch, like what would you do differently? You can either answer both or just one of you.
I guess if we had to start from the scratch, we would probably look a bit more into the, say, TensorFlow and how it works, because like for all four of us, when we started working on it, we basically had like pretty much less knowledge on deep learning and all of this research stuff. And because a major issue we faced was while integrating it to TensorFlow, so we'd probably put on more effort towards getting that part right first. Yeah.
Okay, thank you, Neeladri.
Can I ask a question? Please go to the slides about ActiveClean. Okay, ActiveClean. About the cleaner part, I was wondering, is it cleaned by human, or is there any algorithms that ActiveCleaner can automatically clean the data?
Okay, so for this, the cleaner right now, it's basically, it will, as mentioned, it will go into the Excel sheet and the user will be the one cleaning the data, because what ActiveClean, it doesn't do the cleaning for you. It's basically sort of a framework so that the model, so that it samples the best possible thing to clean, and using that clean data, it goes to the place that is what do you call it? The best possible convergence gradient. Yeah.
Okay, if I'm not misunderstood, which means that the active cleaner only use kind of like active learning to pick up those samples that are be more likely to be mislabeled than if it asks the user to clean it, and use the gradient to help train the model, right?
Yeah.
I see. Okay. And I think maybe this part can be modified to introduce some algorithm to make it automatically relabel. Yeah.
Yeah, there could always be like, some additional algorithms given for the cleaner, and not just have only the user clean it, but also have something of sort of an algorithm to help in the cleaning process. Yeah.
Okay.
Xiaomyao, that's a good idea. Yeah, that you can expand further. Yeah, to automate that part. I think there are various ways possible. Yeah.
And that's why we try to make our code, our refactoring as sort of modular as possible, so that it can replace each component in the future.
Yeah. So next time we can try to have a, I don't know, maybe an automatic classifier to see whether it's clean or dirty, and then yeah. Good. I think the lesson to learn here is also, I think Xiaomyao has a good example here. When we read paper, we also look for areas that we can improve. So this is useful. Yeah, to identify new research problem and opportunity. Good.
So I suppose like a natural next question would be whether either Wei En or Neeladri have found any area where there could be some form of improvement, whether it's the updater or the cleaner, an improvement that could be novel.
Could you repeat that part? Your voice spoke up a bit for me.
So I was just wondering, like, a natural extension to that question from Zhan would be whether that you've identified during the past 3 months any area of ActiveClean where you could potentially improve it. Yeah, so if you go to the diagram, like, is there any one of these components that you could potentially add something novel to potentially improve it, whether it's the updater or the cleaner?
Yeah, definitely. I think the one part that can definitely be improved is the updater, because as mentioned, the paper only talked about working with SVMs, and to elaborate a bit on that, their updater method basically had the loss function be a weighted sort of, not average, I think a weighted sum of the clean data's gradient and the non-clean data or the dirty data's like loss function, and then added them together. So they showed that it worked for SVMs, but then I think because maybe it was an old paper, they didn't really mention anything about say the deep learning models or anything of that sort. So I think that's one part, like making a generalized way of updating this entire for a generalized method for the updater. I think that's one part where we can definitely improve.
Yeah, so things like transformer models and these kind of like models that have come out recently. Since it's a 2016 paper, they haven't really tried on something like, I don't know, Bert or Roberta or Albert, which only came out a few years ago.
Yeah, I think implementing that, like integrating that with the, like using something like transformers for the updater, I think it could work.
Okay. Any further questions?
Hello. I want to know whether the data is task specific, like because lots of models have its goals, like the classification or the regression or something other task, right? But for what's the definition of authority data is dependent on the task, right? Like anomaly detection is different from others.
Sorry, I didn't quite catch that question. Could you please repeat?
Yeah, I think I roughly catch that question, so maybe I can repeat it. So he's asking whether it's basically task specific or like data set specific. Is that right? Yeah.
Okay, so the code they gave was very data set specific. The code provided by Krishnan, I think it only applied to IMDb data sets. So that's why we try to sort of refactor and extend the code so that it's not data set specific.
By the way, except the generic data type like the image and the tabular data, have you considered about like some graph data or some language data? I think these can also be a potential extension. Like graph data, they are not IID setting, and so they can like modify the ActiveClean to target for graph data.
To be honest, we are not like, we just started with deep learning and I'm not really sure what do you mean by the graph data. I think we haven't really heard of it that like right now, but yeah, it can definitely be extended beyond like just images and like normal data, like supervised learning sets. It can all of course include like maybe say language models or something of that sort.
Okay. So that these are all, I think, potential for the expansion of this work that is kind of quite early and preliminary, I would say, right? Yeah, but it's good framework to understand, data cleaning. And I think the topic of data cleaning is coming back as I think it's interesting to see that to spend more time on cleaning the data rather than tweaking the model, right? Or both. So that would be quite interesting. I think kind of interesting introduction to us. So good. So I'm glad there are quite a lot of questions that people ask. Yeah. Okay. If there are there any further questions? Everybody? No? All right then. Brian, okay, we'll stop this session.
Yeah, okay, perfect. Thank you so much, everyone.
Thank you, everyone. I think you can still ask each other questions physically in the lab, okay? All right, then.
Definitely.
Thank you to the two students. Good work. I think you learned a lot as a second year or third year student already. Yeah.
Thank you.
Okay.
Thank you.
Thank you very much.
Bye, everybody.
Okay, bye, bye-bye.
So close